Yeah, the reason why we can't just leave it the way it is because we need it to be in a quadratic format, right? It's the general polynomial format that we're used to, that trinomial, where the first, or the degree of the polynomial is 2, and then it kind of, the degree decreases, right? This is degree 2, this would be 1, and then 0. But what you're going to notice is they're still going to give us a trinomial, but usually the middle term is you could, when we compare the x's or whatever the variable is, they won't always use x. But if they use x, you'll see that the exponent for the middle term is either half of the exponent for the first term. To put this a different way though, like what I'm showing here, usually we compare the first term here with the second term. So I would say, I always look at it and I see, oh, this exponent right here is double whatever the second one is, okay? And what that does is that allows us to change the format, and that's why we say we're going to substitute. This is not necessarily substitution like systems of equations, but it is similar. It's just now we're substituting a base with a specific exponent. So what we do is we say, look at this middle term right here. Instead of showing it as x to the power of p, we say we're going to let this happen. Really, I like to say that we're going to force this to happen because I don't want to see this x to the power of p, whatever it is. I don't want to see that garbage. So I just say, look, I'm just going to change it into a u, because an individual letter like this one is a lot easier to deal with than x to the power of, let's say, 5, okay? And when I do that, now instead of showing as x to the power of p in the form, I have, because it was b times x to the power of p, since I've replaced that with u, then I have b times u. And then you can see this really just changes back into its regular quadratic form. Now, after that, then we solve that quadratic and replace the u with x to the power of p. So once we get because we're going to solve this quadratic for u, and I don't really understand why they used u, but they did. Then we replace it back with this and then solve for 0, okay? Check your answers in the original equation. Always do that. It's always, I can't guarantee that all of the answers that you get will be actual solutions. So you do need to check. But again, the calculator should help us to do that. So do not forget to replace the u at the end. I put that part at the end specifically for me because I tend to forget to put it back, to replace it back, right? Because u does represent some kind of expression. Sometimes it's just x to the power of 2, x to the power of 5, but sometimes it's 3x plus 4 to the power of 8, that with parentheses. And then if you don't replace that back, then you've solved essentially for the wrong thing. And so you got to replace that back. Right now, while we're getting used to this, generally speaking, these are factorable. Okay. Could you use the quadratic formula to solve it? You could. But if I remember right, some of these just kind of lend themselves towards factoring. So I think that's what I'm going to stick with today. All right, so here we go. This one lends itself to substitution. We'll call it U substitution because mathematically, us math nerds like to use U because that's what we were trained to do, I guess. All right. So on this one, this one's not asking us to solve. It's just saying, can you tell what you're going to substitute as U? Yeah. Well, yeah. So here's the thing: is that if I were to take the U and what am I replacing with U? I feel like there's a good X joke that goes with this, but I'll skip it. So here's what I'm going to do. I'm going to take that 5x minus 3. Now again, it's not just the base. Remember, I see these exponents here, right? And sure, the 5x minus 3, I see it repeating. Sometimes it's just an x, but now it's 5x minus 3, and that's fine. But I see that this exponent, this leading exponent right here, is double this middle one, right? We always have this constant, so I'm not ever expecting to see any x or exponents with this term. But I do see that this exponent is double this one. Okay, so that tells me that U substitution will work, but it's usually always, it should be, this middle, again, it's not just the base, sometimes it's just x, but also the exponent. So it's actually 5x minus 3 in parentheses to the power of negative 3. Now here's what happens when I do that. So if I were to look back at the original equation, it's not asking us to do this, I'm just showing you because we're going to. Okay, so I'd have 20, and then I'm just looking at the coefficients right now. Plus 6 equals 0. So here's what happens. Well, I just took this 5x minus 3 to the power of, all that to the power of 3, and I said instead of it being that, I'm going to make it a u. All right, now here's the other thing that happens is we got this 5x minus 3 to the power of negative 6, but that's not 5x minus 3 all to the power of negative 3. Well, what happened was essentially we took this and squared it. So I'm just really multiplying that exponent. And so then u squared equals, it's the same thing, right? It's the 5x minus 3, but now it's to the power of 3 times 2 would be negative 6. So that's why we were able to replace this with u squared. And now it is a quadratic, so you could technically, if you wanted to, solve this with either the quadratic formula, maybe factoring works. I think I tried the factoring, but just to see what would happen. I don't remember what happened, but I don't think it worked. In any case, we didn't really need to go that far. The only thing we needed, let's come back here and just show the substitution that we needed was this part right here. Okay, so again, it's not just that you're taking 5x minus 3 and replacing that with u, you're taking the 5x minus 3 base and the exponent from that middle term and then replacing it with u. Now, even if we were to solve this, which we're not. No, it didn't ask us to solve. We're gonna solve the next ones. But if it did, if we were to solve these, then we would have to make sure once we solved for u, that we would have to replace that u back with this garbage right here. And then we would solve that garbage.